Hey everyone, Donovan Brown here. Welcome to the DevOps for ASP.NET Developer Series. In this episode, we're going to focus on unit testing. Unit testing is critical to delivering high quality code. Using Azure pipelines, you can run any unit testing framework during your build. The results of the build can be shown on your build summary and on team dashboards. Let's see how Abel and Jeremy add unit testing to their project.
Abel, I have a question for you.
Sure.
I found out after compiling my application, worked fine, ran it locally, deployed
your
it.
machine.
Yeah, worked on my machine. And we went through a few ways to get it actually deployed, which was great. Turns out my boss wasn't too happy because they said that I needed to focus in on testing.
Right.
And my first response wasn't testing for the QA team. And it turns out that there's probably more I can do as a developer, and we have this concept of unit tests.
Right.
That is actually supported as part of Azure Devops.
Yes.
But before we even get into how it supports testing, I'd like to better understand what is the value and approach to unit testing.
Perfect. I'm so glad we're talking about this because unit testing is one of those subjects that I'm really passionate about. I'm a huge fan of unit tests, but I have not always been a huge fan of unit tests. I used to hate unit tests. But the theory behind unit testing is every line of code that you write that does things, you should also have other lines of code that test it to make sure it does what it's supposed to do.
Okay.
Right. So think of like a calculator function like an add function. You pass in two variables and you add them together and you return back a value, right?
Right.
So that function right there is super easy to write a unit test for, right? Because you can say, okay, add 3 plus 2 and the answer better be 5. Or if I add -3 plus -7, it better be -10, right? So you can see how writing tests like that would be useful.
Okay.
Yeah. However,
it feels like a lot of work.
Exactly. It totally is. And I wish I could pretend that it's just, oh, it's super easy to do, but it's not. It is more work. And you know, when I first looked at this, my first thought was, great, now you're asking me to write double the amount of code. Right? First I have to write the implementation, then write the tests that test it. And the answer is yes. Although it's not quite double. I would say it's about a third amount of time that you take to implement, so about how long you have to write unit tests. But they're super, super valuable. And here's the thing. When you first write unit tests, it seems really silly. Why am I doing this? Why do I even care? How is this even helping me maintain quality, right?
Right.
The important thing to remember, though, is for us, developers, fixing bugs is not hard if we can reproduce the bug, if we know the bug is there. Then it's really not that hard. Set a breakpoint, game over, right? You just go in there, figure out what's wrong, and fix it.
Sure, if you can set a breakpoint. If it's running in production,
right.
That's not necessarily the case.
Right. But the big thing for us is, if I know the bug exists and I can reproduce the bug, I can fix it. That's just the way it is. But the problem is, a lot of times, think about when we're writing code, not when we first start out the project and it's tiny, but it's been running for a while, right? And somebody asks us to add some functionality. So we go in there, we add the functionality, hooray for that, we're awesome. And then we broke the app in 4 different places.
Right.
Has that ever happened?
Never in my career, but I have heard stories.
Clearly, I don't write bugs ever, so I've heard other people that happens to them.
My code always does what I tell it to.
Right. So that's really where unit testing comes in, right? Because if I have unit tests for all of my code that tests how my code should behave, and I go in there and add a new functionality, or I fix a bug or something like that, I can add that new functionality, I can break the app somewhere down the line, but my unit test will catch that, right? So immediately, I can find it, fix it, set a breakpoint, do whatever I need to, and I can quickly fix it. That's where the value comes in.
So it sounds to me like this, we could almost think of a submarine, right? That's underwater, and suddenly you get a hole, and the hole starts leaking, so that's a broken unit tests. The
Yeah.
unit tests are sort of an alerting system to tell us,
Yes.
this change caused this problem. Maybe I increased pressure too much. I don't even know. I've never operated a submarine. But what's interesting to me is when I look at code, there's some code that is like a big hunk of metal all fused together.
Yes.
And it seems like that code would be tough to test.
Yes.
There's
very
other
tough.
code where you have, firewalls and you have bulwarks and you have ways of partitioning the damage so that, let's say we spring a leak, it's compartmentalized in
Yep.
a certain area.
Yep.
So extending this, I'm just working through this in my head. It feels like taking on unit tests might also change the philosophy of how you build the code to make it more testable.
100% true, right? So in order to be able to write unit tests, your code needs to be testable, right? You have to write your code in such a way that it's testable. Like you said, if you just have some big giant monolithic spaghettied code that's all intertwined together, how are you going to test that? That's impossible, right? There's no way that you can possibly do that. So when I first started writing unit tests, well, my first reaction was, F this. This is it takes way too long, and it's such a pain in the butt, because it is a pain.
Right.
And I didn't really see the value until I really started using it. But once I started writing my tests, I realized that I now need to write my code in such a fashion that it's testable. So that did two things. Number one, it changed the way that I wrote my code. And number two, consequently, my code became much better quality because it's written in a testable fashion, so it's no longer spaghetti together.
So that actually is interesting too, because it feels like it could go almost back to the design and the specification piece of this too. Because when I think about writing tests, there's two approaches. There's you write a piece of code and you could test it.
Yeah.
Or maybe you get a story on your backlog
Yeah.
and you write a test for that story and you make sure the code does that.
Yes.
If someone tries to come to you and say, this function should return quickly,
Yeah.
I don't know how to write a test for that.
Right.
But if someone says this function should return in less than 2 seconds,
Yeah.
now that's more precise. So it feels like there should be a dialogue that goes on that says everything from the story down to the code should be testable, and if it's not, maybe there's something going on higher up the chain, so to speak.
Right. Absolutely. And I'm glad you brought that up, because like you said, there are a couple different ways to write your unit tests. When I first started writing unit tests, it was basically every method that I had, I would write a unit test for it. So as I wrote the method, I would quickly write a unit test that would test that specific method. But that kind of requires a lot of knowledge of what that method is going to do, and there's nothing wrong with it. It's a perfectly okay way to write your unit test. But then I ran into a friend of mine who showed me how to do behavioral-driven development. So at first I was doing test-driven development, right? Where you write your test first, and then you write your methods. But my biggest problem when I was doing just straight TDD was, as I was writing my test, I was like, I have no idea how to even begin to write my test, because I don't even know what the method's going to do. So then I would kind of go into the method and kind of jump back and forth, and that worked okay. But I like this idea of BDD, the behavioral-driven development, where you describe the behaviors, and it's pretty much exactly what you just said. Here we have a user story, and for this particular user story, these are all the behaviors that I want to happen. Right.
Okay.
Whether it needs to return back within 2 seconds, or maybe it's when the user clicks on the upload button, it's gonna take that data and put it into the database and in these tables, or whatever, right? So I mean, using behavioral-driven development, number one, your test becomes super readable, and the other thing is, wow, to me it's easier conceptually to figure out, okay, these are the tests that I need to write, and I do like the readability factor, and I'll show you that in a little bit.
Well, it sounds like some tests, because obviously I haven't been testing properly, but I have come across tests in the field. And you see this format of given something, when something happens, then expect a result. So I've heard of 2 different ways to approach. There's arrange, act, and assert, which feels like implementation detail of the test. And then there's given, when, then, which sounds like the expected behavior of the test.
Right.
And
right,
it
right.
sounds like if you can write a test that says, given these, when this happens, then that happens, that can go all the way back up to the specification being written
absolutely.
for the piece of code.
Absolutely. And then it becomes super, super powerful, right? Super easy. All of a sudden, your tests become very readable, and those can be used as part of your specs. Right?
So would you say tests are a way to almost build trust in the code base as well? That if I'm in a large code base with 19 other developers, if I have tests, do I feel more confident about changing my code and checking it in because I know at least the tests that have been written have run?
Yes, yes. So you can think of tests as, at this point in time, this is how my code is behaving, or this is how my code should behave. My code should pass all of those types of tests. So if I need to go in and add functionality or fix a bug, we're always afraid that we're going to like mess something up, right? And the test gives us that peace of mind that even though I made these changes, the rest of the behavior still is the same. I think one of the best examples that I can think of in my career, I was given, this is quite a few years ago, but I was on a project and I wrote this data layer. This was before Entity Framework and all that nonsense. I wrote a data layer that connected up to SQL Server, right? And I embedded a bunch of SQL and all that nonsense. I wrote it really badly, but anyway, that's what I did. The client came back to me and said, "That's great, but we don't want to use SQL Server. We want to use MySQL." What could go wrong? It's all
Right.
SQL, right? So normally I would have panicked and freaked out and just said, "There's no way I can do that." But luckily, I wrote very, very extensive unit tests. So because of that, I just went in there, tore the code apart, ripped it into pieces, rewrote everything, and ran my unit tests. And immediately, like 5 of my tests broke. But I'm like, hooray for that, it broke, let me go and fix it. And then eventually everything turned green, and I was like, oh, let's see if this really works. And bam, it just worked, right? So it gives you that peace of mind to dive into your code, refactor, or add new functionality, or do whatever you need to. You have these tests that will kind of guarantee in a way that the quality is at a certain level, or the behavior is going to be what you think it's supposed to be.
So before we look at how we scale this, because obviously everyone running unit tests on their laptop is one thing, but how do you really know people have taken that step? I understand there's a difference between unit tests and things like integration tests,
right?
For example. So how would I test something that interacts with a database layer if I don't know that there's going to be a database available, for example?
That is a fantastic question. So the idea of unit test is you only want to test one unit of work. So if my unit of work includes hitting the database, getting data, bringing that data back, and then manipulating it in some way, right? That seems pretty common.
Sure.
My test should test the logic of manipulating that data. It shouldn't test the logic of, is my database query correct?
Right.
I'm going to assume that's correct. That's not the important part. The important part is my logic correct? Now, the reason why I want just that one unit of work is because when this test fails, now I'll know exactly where the test failed. Did it fail in the database query, or did it fail in my logic? Well, I know it failed in my logic and not the database query because I'm not testing that, right? So that's the theory behind you want to test one unit of work. The other thing, though, is when you're testing, for instance, and you have an outside dependency like a database, how are you supposed to test that? Right? Back in my day when we first started doing this, we would have a special test database,
right?
Special data, known set of data, right?
Sure.
So then before you ran the test, you need to make sure the data was in the right state. Then you would run the test, and then with the known set of data, it would return back the known set of data. And then after your test, you have to clean it up and revert it back to the same state.
Right.
Kind of a pain in the butt, very, very fragile.
Sounds like if you had 1,000 tests, that would take a really long time to set up and run and tear down too.
It would take for freaking ever, right? When you make a call to the database or make a call to a web service, number one, you have to have the database out there, or the web service out there, or the API sitting somewhere, right? You have to have the stuff there for you to actually test these outside systems. You can do that, but like you said, very slow, right? Number one, it's super, super slow. Number two, now we have no idea if it breaks, we don't know, is it breaking because the data's bad?
Right, is there a poor setup?
Yeah.
Right.
Or is it my logic? So we can have broken tests, red tests, and no clue, is it really the logic that's broken or the whole setup that's broken? And to make matters worse, what happens if you have more than one person trying to run these tests at the same time? They start walking on top of each other's data, then it turns into a giant cluster. Right?
Sure.
So to mitigate all of that, we want to do something called mocking, right? Where instead of making a call to the database, now I'm going to make a fake call to the database where I don't really go to the database, but I'll just return back my known set of data. So this way, I don't even have to have that database out there. I don't even have to have anything deployed. I don't have to have my web services, my API layer, or anything, right? Because I'm going to mock those calls out. So if the call is to return me the top 10 most frequented items in my catalog, instead of hitting a real database, I'll just be like, okay, this is the method I'm going to call, or this is the SQL method I'm going to call, and this is I'll just say return back this specific data. And I'll show you some examples of mocking as well. But mocking is extremely important, right? Any outside dependencies you want to be able to mock. You want your test to be able to run independently and run super, super fast. So.
And by mocking, we mean have a pretend implementation, not make fun of the database. You're a database!
Right,
All right. Sounds good. Terrible joke. People call that dad humor. But let's talk about the fact that I'm sold now on unit tests.
Yeah.
I obviously can build them and run them here, but there's a component of Azure DevOps that also recognizes and integrates unit tests as well.
So Azure DevOps, you can do whatever types of unit tests you want, right? So you can write unit tests using MS Test, you can write unit tests using XUnit, NUnit. There's all sorts of different types of unit testing frameworks, and Azure DevOps supports them all. So why don't I jump in and kind of show you how you can set all that up.
Sounds great.
All right. So on my screen right now, I have some code for our Hotel 360 app. And this one here is the controller for the testimonials. So in a nutshell, if there's an API that I can run and hit that will get me all the testimonials for this particular hotel.
Okay.
So what it does is it hits my testimonial service, and it calls the get testimonial method.
Okay.
Right. What's kind of cool is whoever wrote this code, they must have thought about, let's make this code testable. Good job. Even though you didn't write the test, you made your code testable, right?
Right.
So what they did was they created an interface, an customer testimonial interface. And if we look at this particular interface, it's pretty simple. It just says, I have one method that says get testimonial, right? So when I go ahead and write, and of course it's using dependency injection. The .NET Core framework is using dependency injection to put in the real testimonial service through this constructor. Right?
Okay.
So that's just .NET Core magic that just
configured up, passed in,
yeah.
We're good to go.
So when I write my test, easy enough to create a test project. Let's go ahead, you just right-click it and say add a new project. And immediately, you'll see in the wizard, it'll ask you, okay, what type of projects do you want to create? And of course, I'm initializing everything. One of the things that it's going to have is different types of testing projects that you can use. So let me go ahead and go to .NET Core. And as you can see, we can do MS Tests, NUnit, and XUnit right out of the box.
Okay.
So I happen to write my test using XUnit. You don't have to. You can use any unit testing framework. I'm actually not super tied to any of them. They do all about the same stuff. There's a little bit of differences here and there, but at the end of the day, it's a unit test, right?
Okay.
So pick the unit testing framework that makes sense for you and your team. So if I look at my test is pretty simple. My idea is if I browse to the testimonial API, let's go ahead and return all the testimonials in a JSON format. So if you look at my index, that's exactly what it does, right? I hit this API, and it's going to return me back all my testimonials.
Okay.
So when I write my unit test, first I create some fake data. I need a customer testimonial, which has a name and then the text. So I create my fake data. Then I'm going to mock out the testimonial service. So instead of having the real testimonial service that goes to our API layer, I'm going to mock this out, and I'm going to mock out the get testimonial. I'm using MOQ, the library mock. There are a ton of different mocking frameworks as well that you can use. I don't care which one that you use.
I feel like if I've been writing tests all along, that would be my favorite framework.
Since you know nothing about unit tests.
MOQ is pretty powerful in what it does.
Pretty standard. Inside of MS Test, there's a mocking framework as well, Microsoft Fakes. I'm kind of a huge fan of Fakes because they're super cool. Although I don't know if it works with .NET Core yet. I know that was on the backlog.
Yeah, that's a good question. I'm not sure either.
Yeah.
But it's really good for those really hairy classes to test that are static and not playing by the rules. It does a good job.
Yeah, the mocking framework with Fakes is freaking amazing, right? Because ultimately, no matter what mocking framework you use, what do you end up with? You have an interface, you implement that particular interface with a mock, and then you just fill out the method that you want and return back whatever data you want.
Right.
But you have to have interfaces, which means you have to go back in, refactor your code to use interfaces like our code right now. It's already refactored in a way that we're using interfaces. What's powerful about Microsoft Fakes is you don't need interfaces. You can literally mock out any object, any method, public, private, static, system, it doesn't matter, right? So it's super powerful and super useful. Like I said, I don't know if you can use it with .NET Core yet. I should have looked that up before we started. But it's a cool mocking framework. But anyway, I used MOQ. So I created my mock. And when they call get testimonial, I'm just going to return my fake customer testimonial.
Okay.
So then I instantiate my controller right here. And I pass in my mock.
Okay.
So now,
that's that dependency injection.
yeah.
And look at that, there's even comments that say arrange, act. And I bet there's going to be an assert.
Look at that, look at that, there's an assert.
So the arrange is setting up the test.
Yep,
The act is executing the test.
yep,
And the assert is checking for the desired result.
yep. So in this case here, my act is I'm going to call my index, and I'm going to get a JSON result back. And now I'm going to, a couple things I'm going to do. The first thing that I want to do is I want to make sure that the get testimonial call, this method here, testimonial service.get testimonial, I want to make sure it actually got called.
Right.
So I'm checking, did it ever get called? Did it get called one time? Because I only want it to be called one time. So that's what my first assert is doing. And then my second assert is I want to make sure that it's going to return back the correct data, which is the fake customer testimonial.
Makes sense.
Right. So that right there is how you can write a particular unit test, right? So now I can check all this code in. During my build, I want to make sure we compile all these unit tests and run these unit tests.
Okay.
So the way that we would end up doing that is, let's go ahead and jump back into our pipeline. Here is our pipeline build. Right. So this is pretty standard for a .NET Core application. The first thing that I do, I scan my source code using white source built for security violations or flaws or things like that. Then I'm going to use .NET Core SDK too.
Okay.
And I'm going to do a restore.
So all the dependencies get pulled down.
Yep, yep, yep. And then after I do a restore, I literally just call, and that's going to build my app as well, I'm literally just going to call .NET test.
Okay.
Right. So if you do everything through the command line, actually, I have the screen right here ready to go, right? So if you're doing everything through the command line, you can just say .NET test, and that will go ahead and build all of your tests and run all of your tests, right? So inside of Azure DevOps, we can just use the .NET task, and here we're going to say, let's go ahead and run test. The command we're going to run is test, and we're going to pass in the argument of -ltrx. So what that says is the output of my test, put it into a TRX format.
Okay.
The reason I want it in a TRX format is because once I have that, I can use the published test results, and it will publish that TRX file, and then I'll be able to see my test results in my build report.
Okay.
Right. So that's really all the magic that's there. I run a .NET test, make sure that I get the TRX file, and then let's go ahead and publish it using the publish task. So once we do that, we end up with a build. Let's go ahead and look at one of our builds and see what the build report looks like. We'll go ahead and jump in here. Let's go into our build summary. And you can see we ran some tests. 100% of them passed. And of course, that's because I'm barely running any tests at all. I have one test.
Right. Wow, 24 seconds to run your test. Can you speed that code up a little bit?
Actually, you can, right? So the first, the first test takes a really long time.
Because it's setting up the whole environment and getting it ready.
Yes.
And then but if you have 1,000, they're not all gonna in 24 seconds.
So you can run these tests in parallel as well.
Right.
Right. So that
Okay.
really speeds things up, especially if you have a really beefy build engine that has a lot of cores. Right. Then you can just run everything in parallel and it goes super fast. So here's the interesting thing about how long do tests run. Unit tests are so important, especially in today's DevOpsy world, where we're continuously pushing code out into production, right? So back in my day, how did we, super old, how did we find our bugs, right? I never used to write unit tests because, like you, that's the QA's job, right?
Right.
So I would write my code, throw it over the wall, grab another user story, I'm done. Grab another user story and I'm off to the races, right? So I'm like, I'm awesome. I've closed out all these user stories, although I might have written a whole bunch of bugs. I'm not going to know that until QA finally finds it.
Right.
And when they do, I'll go and fix it, right? Or maybe I'm off to another project and some other poor fool has to fix my bugs for me.
Right, exactly.
The problem with that approach is for QA to find it, they have to run functional tests. And they have to run end-to-end functional tests to find any of the problems if it's buried way down deep, right? End-to-end functional testing, how long does that take?
Long time.
For freaking ever, right? Easily, you can do end-to-end functional testing for 2 weeks. Easily, you can do end-to-end functional testing for 3 months.
And by then, I've already forgotten the code that I wrote. So when they come to me with the defect, I'm like, who wrote this? Oh, that was me.
Oh, and then you look, you're like, what was I doing?
Right.
2 things happens usually, right? I look at my code and I'm like, who wrote this? Idiot. Oh, it's me. Or sometimes I'm like, oh, that code's beautiful. I'm amazing. Right?
That's usually what I end up with.
Of course, right? That's we don't write bugs. But so in a DevOps world where let's say our sprint's 2 weeks long, and we're pushing into production every 2 weeks, how are we going to maintain quality if our testing, end-to-end functional testing, takes 3 weeks to do? So every change that I have to do requires the QA to do the whole end-to-end testing again. How are they going to keep up? Right? They can't.
Right.
So how do we maintain quality in this DevOps world where we still can push code out really quickly? And the answer is we moved, well, if you look at what we've done with Azure Devops, so the Azure Devops product, so that team, we used to do end-to-end functional testing, and it would take close to 6 months to do full end-to-end testing. So we're shipping new code every 3 weeks. So clearly, something
That's not acceptable, right? Yeah.
So we started moving away from functional testing. Our first thought was, let's do automated UI testing. So we took all our functional testing. We spent $1 gajillion to have people write automated UI tests, and they did. And then we would run them. And 2 things happened. Number one, it would take forever to run because automated UI testing
Has to render the UI, parse the UI, exactly.
Yeah. The other thing is, anyone who's written automated UI tests knows that they are extremely fragile.
Right, you move the button, change the button name, add a new text box.
Super fragile, right? And to make matters worse, we always had those instances where you run the test and it would break, you run it again and it would work. Nothing has changed, right? I just ran the test 2 times. Ran it the 3rd time, it might work, it might not, who knows, right?
So you uncovered quantum computing without realizing it.
Well, yes, sure. So it's, that had the result of we never had a full test run that was all green. They were always red.
And then you made exceptions, worked around them, patched it up, got it out the door.
Eventually, we just started ignoring those red tests
Right.
because it's like, oh, I'm sure it's just a fluke, right? And then you ignore it. So they basically turned useless for us. So we moved away from functional testing, whether it's by humans or automated UI, and then we moved our efforts more to the dev side, right? We shifted left. So now we're going to try to test everything using unit tests. Very, very detailed, very, very careful unit testing. Every single pull request that we do has to pass our tier 1 and tier 2 unit tests. So those are our fastest running unit tests.
Right.
So just to give you an idea what that looks like, check this out. This is my engineering dashboard for Azure DevOps. Of course, it's rendering right now. I need to find my pull request. Here we go. We'll go ahead and jump into this live. and we'll see a pull request that's actually going on. Let's go ahead and just grab any one of these. Let's grab a green one. So here's a build, right? You do a pull request, it kicks off a build.
Completely automated.
Yep. If you look at our summary and you look at our testing,
wow.
every single
74,000.
Yes. How do we maintain quality at a pace where we're pushing code into production once every 3 weeks? And what we don't usually tell people, but I guess I'll just tell the world now, we push bug fixes multiple times every single day. So how do you maintain quality when you're moving at that pace? The answer is every single developer check-in has to pass 74,000 unit tests.
It's like 74,000 QA bots checking off
Yes.
little pieces of code.
That's how important it is. And of course, all 74,000 ran in about 20 minutes.
Nice.
Right. And if you want to parallelize this even more, or you just even beefier machines, you can get that number way down as well.
So the only other thing I wanted to touch on is my understanding is that with these unit tests, because you're publishing them and Azure DevOps is aware of them, you can do creative things like automatically issue a ticket for me if one of my
Absolutely.
tests fails.
Yep.
And block my code from being pushed into the main branch.
Absolutely.
Because it's defective.
Yep, and that's exactly what we're doing with the Azure DevOps team as well. If my pull request, if the build breaks, that code, nobody even reviews it. It just automatically gets rejected. Your build needs to succeed. But our build is not just, it needs to compile, which is of course super important, but it needs to pass all 75,000 tests as well.
And you have different tiers of tests based on how complex they are, how
Yep.
long they take to run,
Yep.
and everything else.
Yep.
That's amazing.
So I don't want to say that functional testing is irrelevant.
Right.
Because it's not. It's still important. You still need eyeballs on the product. You still need to do some click testing of the UI itself, whether it's automated or human or whatever. I mean, you still need that. But the big bulk of your testing effort needs to be on the developers to write good unit tests and not just bogus tests, right? I can write 100 tests that gives me 100% code coverage that doesn't assert a thing.
Right.
Right. So your tests have to be good. So to make sure that our quality is good, every pull request, well, you have to have reviewers, right? When you review it, not only do we review, let's say you do submit a pull request, I'm not only going to review your code, I'm going to review your tests as well
Right.
to make sure your tests are good. Because when the product breaks, I don't want to be if I'm on call, I don't want to be called to fix your bugs that's running in production, right? So quality needs to be maintained everywhere.
And that actually draws to mind the kind of last piece of the puzzle for me, is that in a code base with well-written tests, I don't even need to go to a developer wiki to understand how to use the code.
Yeah.
The tests not only explain what the code's supposed to do,
Yeah.
but they demonstrate how to use the code. And
Yeah.
as a developer coming onto a project, that lets me onboard more quickly as well.
Yeah, and that's one of the reasons why I love the whole behavioral-driven development, right? Because your tests become so readable that you're like, oh, I know what's going on. So let me give a quick example of that as well. If I look at some code that I wrote for Donovan, I have a whole bunch of tests. Of course, the font is really tiny, so you'll have to jump in here. But one of the
Just adjust my glasses. Okay,
There you
zoom
go.
in.
So I wrote all these tests, and I wanted to make them very readable. So anybody could just look at it and be like, oh, for instance, manage headshots for advocates. From the view advocates, I add a headshot by clicking on it. All right. So if I jump into my code, that's literally what it's doing. It's just testing to make sure that when I click the upload of a headshot, that it actually does what it's supposed to do. If I look at my code, let's go ahead and jump in here. What it's doing here is basically I get the file that gets uploaded, right? And then from there, I'm going to upload it into my database. But first thing that I'm going to do is I'm going to check, did they actually include a file or not? If they
Right.
didn't, route it to an error page. And if they did, well, grab it in a memory stream, wrap it in my object, then push it into my repository.
Nice.
So then my unit test needs to test this, right? It needs to test that logic. So that's what it does. But now my tests become very, very readable. If I enter an empty file list, well, make sure I write back to the view or something like this, right? So that kind of goes back to your whole thing of, even if I'm jumping into a new project or I'm jumping into sections of code that I haven't looked at before, I can look at these tests to help me figure out what is my code actually doing.
I'm sold.
All right.
I'm going to go write some unit tests.
Let's go write some unit tests.
All right. Awesome.
Super, super important. I know they're a pain in the butt, but it's kind of like, would you build a house without putting down a concrete foundation first? You could. You build your house much faster. Might fall over eventually.
Right.
Right. So
pay for it in the end.
Yeah. Pay for it in the beginning, not the end.
Right. Sounds great. Thank you so much.
Absolutely. Thanks, man.
Hi, I'm Jeremy Lickness. You've watched another episode of On.net. Thank you for joining us. Be sure to like and subscribe so that you don't miss a show. And if you're interested in more shows, check out the link right here. Thanks.